Next speakers are Linda Zheng from the Harker School, who is a high school student, and Professor Yi Zhang from University of California, Santa Cruz. The title of the paper they will presenting is Knowing You Don't Know, Learning When to Continue Search in Multi-Round RAG Through Self-Practicing. Let's welcome our speakers.
If someone control the slides, or I need to get this. Okay. Thank you. I'm Yi Zhang. I'm the professor in University of California, Santa Cruz, and I'm presenting this work together with my PhD students, DG Yang, who cannot make it here because of visa reason, and also with Linda Zheng, as you know, she's a high school student. And Jimin Rao, who is a visiting scholar in my lab from DeepMind. Thank you for your attention. So, why multi-round RAG system fails? There are many reasons. Here are two major failure modes. Okay. Number one, sometimes the language model will hallucinate answers without solid evidence. This is what we call overconfidence generation. In this example, the retriever either just retrieve one round or 0 round and give out the wrong answer. And another kind of failure is because the language model has poor control, like the retrieval control. It can stop retrieving things earlier before it gets the evidence for the answer. Or it can continue retrieve for multiple rounds and getting a lot of noisy, irrelevant information. Those are errors made by RAG systems. And behind it, why it behaves like that? The fundamental is language model cannot reliably tell its knowledge boundary. Do you remember the keynote speaker, the last slide? It mentioned they hope AI can tell its knowledge boundary, or tell what in our paper it means language model not tell when it doesn't know. And know you don't know actually is a fundamental human intelligence. And even back 2,400 years ago, philosophers from the East and from West all recognize this. And the Nobel Prize winner like Richard Feynman, physicist, Stephen Hawking, they all recognize it. And in today's keynote speaker, he mentioned AI should recognize its state of knowledge is incompetent or inadequate. And this is the motivation of our work. In this work, we propose a solution we call SIMRAG. It stands for Self-Practice Inner Monologue Learning for Multi-Round RAG. Okay, behind it, there is a main idea. We view multi-round RAG as a multi-step reasoning process, which we call inner monologue inside the RAG system. Like inner monologue in your brain, we call this inner monologue inside the RAG system. And in our SIMRAG, we propose to train a separate critique model to check the knowledge boundary of the language model and evaluate both the answer and the reasoning process, which we call inner monologue of the RAG system. What we propose has 3 major steps. First, the RAG system will do some self-practice to generate training data to train the critique model. Step 2, then the critique model will be trained using labeled procedure data we generated from step 1. And finally, with the critique model, a RAG system can do multi-round retrieval, generating more reliable results. Let me explain SIMRAG for the last step first, how it works in action. In this SIMRAG framework, we have language model-based reasoner. At each round of the retrieval, the reasoner will generate an answer and rationale and pass those information to the next step sufficiency inspection, where the critique model will check the answer, the rationale, and retrieve the documents in the past rounds, and to check whether the reasoning paths support the answer or not. If it thinks it's sufficient, the answer will be returned back as the final answer. If the critique thinks the reasoning path doesn't support the answer, it will label it as insufficient. Then it will trigger the next step in further information retrieval, generate a new query to search, and update the context for language model to generate the next answer. And then we continue the loop until the critique says it's sufficient. Okay. So this answer, the critique check, and the search, this loop continues to make sure the final answer is accurate and well supported by the reasoning path. So the question is how we train the critique model. Ideally, what we want are procedure reasoning paths with question, reasoning path, and answer and the label of it. Such kind of data is very expensive to get. And what we propose is a self-practice method, try to generate such kind of expensive data in a cheap way. To do that, we seed with question-answer pairs. There are tons of question-answer pairs in benchmark datasets. And in this framework, we run the multi-round RAG system. At each round, we will, after the language model generates the answer, we will compare the answer with the true answer. If the true answer is, they are equal, then we label this reasoning path with the answer as correct and we accept it. Otherwise, we label it as a negative data and continue the next round of retrieval. So by doing that for a question-answer pair, we will generate many reasoning paths with label of whether it's sufficient or not. With this training data, then we can train the critique model that can critique reasoning paths. This is based on supervised learning, very straightforward, a classifier. We train it to maximize the likelihood of the label. Okay, so before I move forward, I want to summarize and explain the design decisions we have in this SIM-RAG framework. Why we design it that way? There are three major reasons. First, we actually want a solution that can plug into any of the RAG system without modifying the RAG system itself. And why it matters because it saves time and computation resources, and it works with open source RAG or closed source RAG. More importantly, it actually maintains the safety and alignment of language models. You avoid tuning language model or break its behavior. So that's number one. Number two, we intentionally introduce a separate critique model instead of language model to critique because we want to avoid the self-bias, self-reinforcement of the language model itself. And the critique is like a teacher or peer reviewer to challenge the flaws and the reasoning paths and catch the gaps of the language model. This separation between the generator and the critique reflect a fundamental principle we have. We think we need the language model to learn and to improve, not from self-confirmation, but from trusted external feedback, like humans do. And here we want the machine to do the same. And the number three, we introduce this self-practice framework instead of extensive manual labeling. The system trains itself by keep on doing multi-round retrieval so that we have a cheap solution. How it works. Next, I will let Linda to explain the experiments she ran.
All right, so does it work? So we implemented and evaluated SIM-RAG on 3 standard RAG data sets of increasing difficulty. The most simple is Trivia QA with a single hop retrieval. Next is 2-hop QA, and next is 2-wiki multi-hop, which is the most complex. We used EM, or exact match accuracy, as our main metric, and we compared SIMRAG against 8 open and closed source baselines. Naive generation directly calls the LLM. Standard RAG uses the initial input as the query and does 1 round of retrieval. And we include many other advanced methods which retrieve dynamically based on the LLM's information needs, supporting both single and multi-round retrieval. We find that SIMRAG outperforms all baselines when using GPT-4 without requiring full model fine-tuning. Another key observation is that on the single hop task, Trivia QA, standard RAG, highlighted in yellow with only 1 round of retrieval, outperforms all other more advanced and adaptive methods, except for SIMRAG, which is highlighted in green. And SIMRAG performs well because the critic learns to judge the LLM's information needs and adjust its search process accordingly so it can support both simple and complex tasks. So we established the importance of the critic model, but what about the way it's trained? So when we compare a small learned critic model compared to a much larger pre-trained GPT-4 as critic, we find that training this small model leads to much higher performance than using GPT-4 critic for more complex tasks like Hotpot QA and 2Wiki. And this is demonstrating the importance of external feedback through the critic, as well as the power of the self-practicing inner monologue data. So what does one inner monologue in SIMRAG look like? So consider the question, when was the character Jack from this film born? So the LLM first hallucinates, leading the critic to reject the answer. Then it searches for the wrong actor, Sandra Bullock, so the critic still rejects the answer. Next, we get closer to the answer, finding the actor's real name, Bill Pullman, but there's still not enough information about this person's birth date. So using the past context, we finally finish the search by searching for his birth age, and we find it. And from there, the LLM gets a correct answer, and the critic, seeing the whole chain, knows to accept this answer. And this is because the critic has seen many similar examples of this chain before. So in summary, in dynamic information environments, we see that multi-round RAG struggles to judge information sufficiency. SIMRAG provides a practical and elegant solution as an effective and efficient add-on to any RAG system due to its easy adaptation, lightweight critic, and low-cost training. Looking ahead, the idea of SIM, which is inner monologue learning, extends beyond RAG. It enables the use of self-practice in models to generate fresh training data with intermediate reasoning steps. Crucially, it allows models to learn not only from common success patterns, but also common failure modes. We release all data open source on GitHub. Thank you for listening, and we'll open it to Q&A.
Okay, thanks our speakers.
Hello. I have a question.
Sorry.
When you're having this SIMRAG, what is the latency compared to a normal RAG? Because it can take many rounds, it seems.
Latency at inference time or training time?
No, when you're live asking a question, how long does it take before you get an answer?
Yeah, sure. So it depends on the complexity of the task. So because it can support multiple rounds, if it's a simpler task, it could be practically the exact same time if it's one turn, if the LM already has the information, again, it's pre-trained knowledge. And then if it's more than that, then for each round, it takes like a few more seconds because it calls the critic and then it calls the LM to regenerate the answer. So yeah, if it's a very many rounds, then it might take much more time.
All right, thank you.
So,
Yeah, it asks you to take more time. You really need the time to do multi-round retrieval.
the mic is...
1, 2, 3. Yeah. Thank you for the presentation. You said that the first step in your SIMRAG framework is LLM generation without context retrieval. And let's imagine that we have a question, the answer to which lies beyond the training set of both LLM and critique model. And when we ask LLM this question, it imagines the answer and the rationale behind this answer. How does the critique model understand that the answer is wrong?
It's all from training data. So we have a lot of label training data, right? Remember when we do self-practice, we have question, documents retrieved, and rationale provided by the language model, and label, and the answer, and the label. And we train the model. That's why the critic knows. If the training data has cases where there is no retrieved documents, but the rationale and the language model is labeled as accepted, then the critic model will learn those patterns. Does it make sense?
Okay, I understood. Thank you.
Yeah. The self-practice generates a large amount of training data to train the model.
So just one quick question.
Hello. Do you think your method can apply to multimodal scenarios? After all, the intervention of the visual information will make the discrimination more difficult and lead to more hallucinations. In multimodal scenarios, your method.
Yeah, I think this method's widely applicable to really any type of tool calling, not just search. And the key here is that the self-practicing stage to generate the data uses the same inner monologue chains as during the inference time. And so if you include images in both the training data for the critic and then the same, similar idea in the inference time, the critic can still learn from the training data to predict during inference time.
Okay, thank you.
Okay, let's thank our speakers again. And then the last speaker of this